If post-training a model on your own database becomes as simple as prompt engineering, the highest volume agentic workload, the retrieval loop, stops being a recurring API line item and instead becomes a one-time training cost. That is the exact premise behind a new joint claim from database provider Neon and Castform. They state a 4B open-source model post-trained with Castform retrieved search results as accurately as GPT-5.6 Sol, while costing 100x less. If true, this specific capability shift directly attacks OpenAI's per-token revenue model, targeting the exact workloads that drive their enterprise billing. Enterprises often stall on post-training because they believe they lack training data. Castform's answer is that your existing, raw corporate corpus is the training data. Raw documents sitting in Neon's leak-based Postgres are extracted and converted into synthetic question-and-answer tasks to build a ground truth. From there, the system initiates a reinforcement learning loop, running thousands of parallel rollouts where the agent practices retrieving the right information. To prevent the model from just guessing the final output, the reward function is decomposed. It grades retrieval, citation, and answer correctness separately to specifically reinforce the search behavior. Crucially, the system forces the model to use the exact same hybrid BM25 and vector search tool during both the training rollouts and production inference. This infrastructure pipeline is entirely plausible. Hit subscribe if you want more technical breakdowns like this. But while the mechanism holds up, the marketing claims built on top of it do not. Despite a sound technical approach, the headline claim that this 4B model matches GPT 5.6 Sol on accuracy is backed by zero data in the published post. To validate a benchmark, we need the metric name, the evaluation set size, the dataset used, and the identity of the 4B model. The post provides none of these. The only visual evidence of performance improvement is an average reward training graph, completely missing values on the y-axis. Then there is the 100x cheaper claim. Castform reaches this multiplier by measuring against a baseline of GPT 5.6 Sol, estimating a multi-turn search request costs about 3 cents end-to-end. They omit a critical pricing update. OpenAI conspicuously kept Sol's price high for complex reasoning, but recently cut Luna's price by 80%, down to 20 cents per million input tokens. Because Luna is the actual competitor for a cost-sensitive, high-volume retrieval loop, comparing the 4B model to Luna makes that 100x cost advantage immediately vanish. There is still legitimate value here. Decomposing the RL reward function to score individual search steps is a smart, transferable idea, and their open-source code example on GitHub is real and runnable. However, without a disclosed model identity, actual evaluation scores, and an honest comparison against Luna, the core benchmark sentence remains an unfalsifiable marketing claim. Until independent public evals are run on a known dataset, you should read this announcement strictly as a solid infrastructure advertisement for database-backed training, rather than a validated threat to the frontier models.